Imagine we're going to flip a coin to decide which of us is going to go on an all expenses paid trip of a lifetime. But it's my coin we're going to use, and I've told you I'm choosing heads. How can you be sure that the coin I've produced from my pocket is fair, and that you do have a 0.5 chance of getting the tail you need to win the holiday? I expect you'll say, well, we'll flip the coin a few times and just check that sometimes it lands on tails and sometimes it lands on heads, which is a good idea. If we decide to flip it 20 times, what outcomes would convince you that the coin is fair? If it landed on tails 10 times, I expect you'll be happy. But what if it landed on tails only 9 times out of the 20? I'm guessing you'll allow this since this is, after all, a random event. But at what point would you start to get suspicious that the coin I'm using is fixed and that there is a less than 0.5 chance it will land on tails? What if it only landed on tails 7 times? What's your gut feeling then? Well, I'm going to tell you that the probability of getting 7 or less tails on a fair coin that's flipped 20 times is about 13%. Now 13% is unlikely, but it will occur every now and again. Is this event unlikely enough, however, for you to accuse me of trying to cheat you out of your holiday by using an unfair coin? Well, as far as A-level statistics is concerned, probably not, since typically it's only when the likelihood of something happening is less than 5% that statistically we'll begin to smell a rat. We call this a significance level, but don't worry, you'll be told what percentage significance level to use. So let's carry out an actual hypothesis test. We always begin with the assumption that the probability hasn't changed or been affected or influenced, etc. We do this by stating H0, the null hypothesis that we assume to be correct. And in our particular experiment, we must assume the coin is fair and the probability is 0.5. Now it's for us to put forward and prove an alternative hypothesis. We do this by stating H1, the alternative hypothesis. And in our particular case, I want to prove that the probability of getting a tail is less than 0.5. If we can't prove this alternative hypothesis, the original null hypothesis holds. I'm just going to draw your attention to the fact that I'm only interested in proving the probability of landing on a tail is less than 0.5. If I had said I'm interested in proving the coin is biased, then I would be trying to prove something different, that the probability isn't 0.5. In other words, that the probability is either less than or more than 0.5. But you can see in this particular case, in the interests of me winning my holiday, I don't care if the probability is higher than 0.5. I'm only concerned with, and hence trying to prove, the probability of landing on the head is less than 0.5. Next, I'll state the significance level I'm going to use. If when I carry out my experiment, what actually occurs is so unlikely that its probability is below this significance level, then I must reject the null hypothesis. Now we're going to find out what outcomes are so unlikely to occur that their probabilities are below the 5% significance level. Now, this is Edexcel AS level, so all our experiments will be binomial experiments. So it's always going to be the binomial distribution I'll be using. If you're following other syllabuses, the principle is the same, but you'll use different techniques to find outcomes below a 5% significance level. Now, here's a table showing the binomial cumulative distribution for our experiment, namely 20 trials where the probability is 0.5. Let's see what the probability is of getting up to and including 7 tails. And reading from the table, you can see, just as I told you earlier, the probability is about 13%. The probability of getting 6 tails or fewer, that's 5.77%. This is low, but not lower than our significance level of 5%. It's only when we consider the probability of getting 5 or fewer tails that the probability falls below our significance level of 5% to 2.07%. And so there we have it. Using a 5% significance level, if after flipping the coin 20 times we get 5 or fewer tails, you can justifiably accuse me of using a dodgy coin.